Welcome back. Today we're hitting section 9.9, representing functions by power series. And we'll start this with looking at some that follow the pattern of a geometric series. Start with f of x is 3 over x plus 7, and we'll center this on x equals 0. If you recall, the sum of a geometric series is a over 1 minus r. So our goal basically is to make this thing look a little bit like the sum there. So for starters, I'll use the commutative property on the bottom there. I'd also like that 7 to be a 1, so we'll multiply top and bottom by 1/7. So I have 3 7s over 1 plus x over 7. Looking a little bit more like the sum, I also want this to be a minus, so we'll just turn the plus into minus a negative. So here a is 3 7s. R is opposite of x over 7. So we have the sum from n equals 0 to infinity of a 3 7ths times r to the n minus x over 7 to the n. So 3 7ths by 1 minus x over 7 plus x squared over 49 minus x cubed over 343 plus etc. forever. Remember, geometric series converge if absolute value of r is less than 1, so this thing will converge or absolute value of opposite of x over 7 less than 1. So absolute value opposite of x is less than 7. So here our radius of convergence is 7. We're centered on x equals 0, so our interval of convergence is at least -7, 7. To actually test it out the endpoints, plug them in, see if they work. I'll let you handle that part of the problem. This next one will center it somewhere other than on just the nice, neat, pretty 0. So this one we'll find a geometric power series centered at x equals 2, for f of x is 3 over x. So they wanted a geometric power series, so our goal again is the same, make it look like the sum. So f of x is 3 over, well, if we're centering it at 2, I know I wanted x minus 2 involved. I can't just arbitrarily subtract 2 and claim the value is the same. I'll also have to add 2. To keep the pattern the same, I'll put it out in front here like the plus 1 is. So convince yourself quickly that if we simplify that, we're back to the original. Now our goal again, just keep working to make it look like this. So we'll multiply top and bottom by 1/2. And finally fix the sign. So here our initial term is 3/2. R is 2 minus x over 2. So we're looking at the sum from 0 to infinity of 3/2, that's our a, times r 2 minus x over 2 to the n. And it converges if our rate is less than 1. So the absolute value of 2 minus x is less than 2. So here r is equal to 2 then. We're centered on positive 2, so our interval of convergence is on 0, 4. Again, you can test the endpoints if you want to see if that's inclusive or exclusive, but we know we have at least 0, 4. Some operations with power series. Let's take a look at a couple of those guys. We'll let f of x be the sum of a sub n x to the n, g of x be the sum of b sub n x to the n. F of kx then is the sum from 0 to infinity of a sub n k to the n x to the n, since each x will have a k attached to it as well. F of x to the cap n, 0 to infinity again, a sub n x to the nn, since a power raised to a power we multiply. F of x plus or minus g of x give us the sum again from 0 to infinity, a sub n plus or minus b sub n x to the n. So we can add or subtract them like with most of our calc operations that we've seen. All right, so let's see this in action. So we're going to find a power series centered at x equals 0. For f of x is 4x minus 4 over x squared minus 4. So in this one, we'll start with partial fractions just to make it a little bit easier to work with. So we'll let 4x minus 4 over x plus 2x minus 2 equal a over x plus 2 plus b over x minus 2. Clear the fraction, 4x minus 4, it's a by x minus 2 plus b by quantity x plus 2. So then we'll let x equal negative 2, that'll knock the b out. So 4 by negative 2, negative 8 minus 4, negative 12 is worth a times negative 4, so negative 2 minus 2, negative 4. B times 0 is 0, so a is 3. And similarly, we'll let x equal positive 2. So 4 by 2 is 8. 8 minus 4 is 4. A times 0 drops out. B times 2 plus 2 is 4. So B is 1. So we'll do the new and improved version of f of x on our next page here. So now we can say f of x is 3 over x plus 2 plus 1 over x minus 2. So it's our a over x plus 2, b over x minus 2. So our goal, again, try to make these look like the geometric guys. So we'll go ahead and use the commutative property. Get our ones. So there's our ones. Second one already has the sign the way we want it. First one, just a quick minus a negative, and we'll fix that right up. So you have 3/2 over 1 minus opposite of x over 2 plus negative 1/2 over 1 minus x over 2. So now we can turn these into a pair of infinite sums. So our first part of the problem, a is 3/2. Rate is minus x over 2, and we'll raise that to the n. Our second one, from n is 0 to infinity, negative 1/2 x over 2 to the n. So we can, of course, put this under one roof. So from 0 to infinity, 3/2 minus 1/2 to the n. We're going to factor that x on both of them. Minus 1/2 times 1/2 to the n. Each one of those had an x to the n attached. Okay, so where these things converge, we're centered on 0. Our rate has to be less than 1, so our rate in the first fraction, absolute value minus x over 2, has to be less than 1. Absolute value minus x has to be less than 2. And we see a similar thing happening on the second one, x over 2 less than 1, absolute value of x less than 2. So r equals 2 for both of these are centered on 0. So our interval of convergence we've got at least negative 2, 2. So that is how far out we can go with this geometric representation of the original function we had on the previous page. All right, so then our last one of the section. So we're looking for a power series for g of x is arctan of x centered at x equals 0. Okay, so one thing that we know the derivative with respect to x of arctan of x is 1 over 1 plus x squared. So we'll start with f of x is 1 over 1 plus x. So that's the same as 1 over 1 minus opposite of x. So here a is 1, r is absolute value of opposite of x. So this one, sum from n equals 0 to infinity of -1 to the n, x to the n. So we find f of x squared from this. So f of x squared, sum from n equals 0 to infinity, -1 to the n, and then we just have x to the 2n. So that's using one of our properties, power to a power, and we just multiplied it as before. So arctan of x, integral of 1 over 1 plus x squared dx plus c. Here we're going to let c equal 0. So sum from 0 to infinity, -1 to the n, x to the 2n plus 1 over 2n plus 1. So we use the antiderivative. So then arctangent of x, just the first few terms of what that would look like, x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7 plus etc. So our interval of convergence, our radius would be when absolute value of x squared is less than 1. So that is, again, r equals 1. We're centered on 0, 0, so our interval of convergence is -1, 1. All right, so 9, 9. I would recommend 1 to 25 odd, and number 39. If you have any questions, please come see me. Otherwise, I'll see you next time. Stay safe out there.